Have a nice day, my dear children. In this video we are going to discuss about Loci. Please subscribe our YouTube channel. The locus of points on a plane which are at a constant distance from a fixed point is a circle. The locus of points which are at a constant distance from a fixed point is a circle. Is a circle. Is a circle. Second one, the locus of points. The locus of points. The locus of points which are equidistant. From two fixed points. From two fixed points. Second one, the locus points which are equidistant from two fixed points. Draw a straight line segment of 10 centimeters on an oil paper or tissue paper and name it AB. Identify the axis of symmetry of the straight line AB by folding the tissue paper such that 2 points A and B coincide, and mark it with a dashed line. Here we fold it. Identify the axis of symmetry of the straight line AB by folding the tissue paper such that the 2 points A and B coincide, and mark it with the dashed line. This is the dashed line. We mark it. Mark point A. Mark a point P1 on the dashed line. Mark the point P1 on the dashed line. Draw the straight line. Draw the straight line P1A and P1B. Draw the straight line P1A and P1B. P1B, and measure and write the lengths. Measure and write the lengths. Here, this length is equal to this length. Or if you like, you measure. Measure and write. P1, the length P1A is equal to P1B. P1A is equal P1B equal 15 centimeters. You write which length you had. Mark several more points on the dash line and measure and write the distance from A and B of each of these points. Here mark several more points. P2, P3, P4, etc. Here now mark P2A and P2B and measure them. P2A is equal P2B. P2A is equal P2B. P3A. P3B. You measure and write the length. P3A equal P3B. You measure P3A is 9 centimeters. P3B also 9 centimeters. P3A is equal P3B is equal 9 centimeters. Mark other point. P4A is equal P4B. Here P4A is equal P4B. Now check whether the distance from the point A and B to each of these points on the dash line are equal and write your conclusion. We take any other point, this point, and this length is equal to this length. When folding the paper as above such that A and B coincide. Point A and B coincide. Point A and B coincide. Observe that the fold line obtained the perpendicular to AB. These two angles are equal. Addition of these two angles is equal 180 degrees. One angle is equal 90 degrees. Then the fold line is perpendicular to AB. We called the perpendicular bisector of the line segment AB. Observe further that the distance from the points A and B to any point you choose on the perpendicular bisector are equal. We choose any point on the perpendicular bisector are equal to point A and B. Now write down the locus points which are equidistant from two given points is the perpendicular bisector of the line joining the two points. P1, P3 is the perpendicular bisector of the line AB. The path of a rubber bushing which is tied to one end of a rope with length meters and rotated by holding the straight rope at the other end as shown in the figure. Here, like this. Here like this. It's a circle. Second one. The path of the tip of a hand of a working clock. What is the path? The path of the tip of a hand of working clock. What is the path of the tip of the second hand? Please tell. Puta, please tell.
What is it? What is it?
The path of the tip of a hand of working clock. The path of the tip of a hand of working clock.
Yeah.
The path of the tip of the hand of working clock.
Anti-clockwise.
What is the path of the tip of a working clock? What is the path? It's circle. Circle, Puta. Circle.
Yeah.
Please write circle. The path of the tip of a hand of working clock is a circle. The figure shows two houses located 50 centimeters. Sorry, 50 meters. The figure shows two houses located 50 meters from each other on horizontal ground. It is required to build a wall exactly halfway between the two houses, points A and B, indicated by a rough sketch where the wall should be built. It is required to build a wall exactly halfway between the two houses. Then it is the perpendicular bisector of the straight line segment AB. It is perpendicular bisector. This is the wall. Where the wall should be built. It is the wall is the perpendicular. Wall is the perpendicular bisector of line segment AB, straight line segment AB. perpendicular bisector of the line, straight line segment AB or AB. P and Q. In the given figure, P and Q are two trees planted on flat ground at horizontal distance 25 meters. Horizontal distance is 25 meters from each other. It is required to fix a tap at the distance of 50 meters from each tree. With the knowledge on Loci, draw a rough sketch indicated how the points which the tap can be fixed are found. It is required to fix a tap at the distance from 15 meters from the tree. Then this is the perpendicular bisector. Perpendicular bisector. Of PQ. Perpendicular bisector of PQ. Perpendicular bisector. And then it is required to fix a tap at a distance of 15 meters from each tree. Then 15 meters from each tree. 15 meters. 15 meters. This is a one point. Here another point. It is equidistance. It is equal this distance, like these two distances are equal. We name this point R1, this point also R2, 15 meters. Points are R1 and R2. It is required to cut a drain equidistance from the trees. Draw the rough sketch and to indicate the location of the drain. This is the drain. This is the drain. It is the perpendicular bisector of PQ. Please write drain is the perpendicular bisector of the straight line segment PQ.